the most basic type of absolute value, y equals to absolute value of x, or y equals to modulus of x. We can also call it modulus. This is going to be different from a line. If it was y equals to x, it would be a line that passes through the origin, a straight line that passes through the origin like this. But in case of absolute value of x, it would not be a line, it would be a V shape. What happens over here is that since absolute value has to be positive, it cannot be negative, so anything below the x-axis is, we just break this down and reflect upwards and make that positive. So it's a V shape that we have. So it is very important, first of all, to memorize what the absolute value function look like. So it looks like this. So this is the x-axis, this is the y-axis, this is the origin, and it would be this V shape. Everything else is going to be built from this basic picture. If we have to sketch y equals to absolute value plus some number, it could be 1. In that case, the entire picture would be lifted by 1 unit upwards. Instead of 0, it is going to cut the y-axis at the point 1. So this is going to be the sketch. Similarly, if it was y equals to absolute value of plus 2, so it would be raised by 2 units. So it would be like this. So this is going to be 2. So 0, x-axis, y-axis. Now, if it is negative, that means the entire picture would be lowered. If we have y equals to absolute value of x minus 3, in this case, what would happen? From the original position of the origin, it is going to be here below the x-axis, and it's going to be minus 3. Now, the difference between this and the previous sketches is that here it cuts the x-axis at 2 points. Now, in order to find out where it cuts the x-axis, we have to put at y equals to 0, because at the x-axis y is equal to 0. So absolute value of x minus 3 equals to 0. Now we have to solve this absolute value equation. So we know absolute value of x equals to 3. It means that the distance from the origin is 3. So it can either be on the left side of the origin, or it can be on the right side of the origin. So it means if you have a number line, this is the origin, we have lots of numbers on the right hand side and lots of numbers on the left hand side. So if the absolute value of 3, it means from the origin it can either be 3 units towards the right, meaning a positive number, or it can be 3 units towards the left, meaning a negative number. So when we solve this, we have to write, therefore either x equals to 3 or x equals to minus 3. So it cuts the x-axis at either minus 3 or 3. On the other hand, when we have y equals to absolute value of x plus 1, then the entire picture shifts towards the left. It would be over here. So it would be at minus 1. When we have y equals to x minus 1, the entire picture would shift towards the right, and it would be plus 1. When I say the entire picture, I'm of course referring to the picture of y equals to absolute value of x, which is like this at the origin. Now, in both the cases, it's cutting the y-axis. If you want to find out where it cuts the y-axis, all we have to do at x equals to 0, what is the value of y? Y is 0 plus absolute value of 1, and absolute value of 1 is 1, meaning its distance from the origin. So this is going to be 1. And here again, y-axis means x equals to 0. So y equals to absolute value of minus 1. It just means from the on the number line, it's on the left hand side of the origin. So this is also going to be 1. So it cuts the y-axis at the point 1. So this is shifting from towards the left and towards the right. Let's do an example over here. So we have a picture, and we also have the equation where the absolute values are given. We have to find the values of a and value of b. First of all, value of b means where does it cut the y-axis. So y-axis means when x equals to 0, then y equals to absolute value of x minus 1 means 0 minus 1 minus 2. So absolute value of minus 1 is 1 minus 2. So this is going to be minus 1. So the value of b is going to be minus 1. Next, for finding the value of a, this point has x coordinate 1. We know that. So when x equals to 1, So y equals to absolute value of 1 minus 1 when we plug this into the equation, minus 1. So when 1 minus 1 is 0 minus 2. So the absolute value of 0, meaning what is the distance of this number from the origin? It is 0. It's on the origin, so it has a distance of 0. So it will be minus 2. So therefore, a equals to minus 2. Suppose you have to sketch y equals to twice absolute value of x plus 1. Now here what we have different transformations over here. First of all, we have y equals to fx, which is absolute value of x. So this sketch is just little v shape. This is pretty simple. We have this memorized. The next thing that we have is we have y equals to afx. That means a number multiplied by that absolute value of x. So this is going to be y equals to 2 absolute value of x. Now since it cuts the y-axis at the origin, so if you multiply by 2, it would have no effect. So it is going to be the same. So y equals to absolute value of x and y equals to twice into absolute value of x is basically the same. The next thing that we have to do is we have to do the transformation fx plus a. So the entire picture is going to be raised by 1 unit upwards. So that picture is going to be like this. So 1. So the sketch over here is going to be, so the y-axis is this. So the x-axis is this. And this is the picture basically. So it doesn't really matter, this 2, that is the coefficient of absolute value of x, is not having that much of an effect on it. Another one could be, suppose you have the entire line in the absolute value. So suppose you have y equals to absolute value of twice x minus 1. The best way to do this is first in the rough to sketch without the absolute value, so twice x minus 1. So when we sketch this, so what we do when x equals to 0, y equals to minus 1. So it cuts the y-axis at the negative 1. When y equals to 0, we can find x equals to half. So x would be equals to half. So the line would be like this, passing through half at the x-axis and minus 1 at the y-axis. When we put the absolute value, so we are basically doing the transformation where the absolute value is put. That means anything below the x-axis is reflected and made into this V shape. So this sketch is going to be, it cuts the x-axis at the point half. This is going to be alright, but it is now turned into this V shape, and previously it was minus 1. The absolute value is going to be 1. Now let's try out the absolute value of the most common Cartesian equation. We have already seen the absolute value of x looks like this. So the absolute value of x squared would be exactly the same as y equals to x squared, because it is already above the x-axis, so it would have no effect at all. Then the absolute value of y equals to x cubed, that is going to be, originally it was y equals to x cubed. This was the shape. This was the original shape. Now what would happen? What is above the x-axis would be here like this, and below the x-axis is going to be reflected. So it would look like this. The shape would look like this. So the whole thing, it would be reflected upwards like this. So this is what the shape would look like. Then y equals to absolute value of 1 by x. Previously it was y equals to 1 by x, and there would be the hyperbolic shape like this. So this time, if you take the absolute value, this right hand side curve would be here, but whatever is below the x-axis would be reflected upwards, and it would look like this. Then we have y equals to absolute value of e to the power x, which would be the same as e to the power x because it is already above the x-axis. So the absolute value of y equals to e to the power x is going to be the same as y equals to e to the power x. But the absolute value of y equals to absolute value of ln x. So this is going to be like this. So previously it was like this, and this is 1, and it goes below. Here it would be reflected upwards, it would be like this.